Hey guys, and welcome back. We are now into one of my favorite topics, exponential growth and decay. And this is actually our last concept of this unit. I know, really short unit. So, with that being said, let's just get into it. So first thing, would you rather? A genie pops out of a lamp and presents you with the following choices. Would you rather receive $50,000 now? Or for the next month, start with 2 pennies on day 1, then receive 2 more pennies on day 2, 4 pennies on day 3, 8 more pennies on day 4, etc. Constantly doubling. And remember, this is just for a month. I'll let you think about it. Okay. So by the end of May, you would have $50,000. That's it. Sounds like a lot. And it probably is. It is. But my other choice, my little pennies, they do add up quite quickly. So by the end of May, I would have 21,474,836 and 48 cents. So it added up really quickly. That is way more than 50,000. If I look around day 22 to 23, something happened there and I surpassed 50,000. Okay, so that is an exponential growth. It starts off very slow and then it just suddenly shoots up there and just takes over. So 2 equations that you need, and these are not on your formula chart. So these are 2 equations that you're gonna have to memorize. And I mean, they're not that hard to memorize once you learn how to use it, but for right now, it's going to be because it's new. So first, exponential growth, y equals a times 1 plus r, parentheses to the power of x. Exponential decay is y equals a times 1 minus r to the power of x. So we've got a is our initial value, r is the rate, usually in a percentage, which we need to change to a decimal. X is your time. Same thing on decay. Write that down. So something that you need to know is when I'm determining between the 2 on growth, the part in the parentheses, as we can see, we are adding 1. So it always needs to be bigger than 1, okay? On the exponential decay, though, we are subtracting 1. So it always needs to be smaller than 1. And that's pretty much it for that. Make sure you write all that down. So first we've got a growth. So see how it slowly and then it shoots up? This is a growth. A decay is the opposite. So we start off really strong and then we just kind of, not plateau per se, because we don't go in a straight line. It's continuing downward. It's just so slight that we just can't see it. Okay, so we're going to do a couple of examples and then that's it. You'll be on your own. So, example 1. Lucas invests $500 in Apple. His investment has an annual growth rate of 10%. So with these, your teak is actually to write the equations. So that's what we're doing. We're writing the equation. So we have to do the following steps. Determine if it's a growth or decay. That's always important. Identify A, R, and X. Super important. You are going to have problems where they literally will ask you, A is what part of the problem? R is what part of the problem? X is what part of the problem? So you need to be able to identify things. Third, input your values. Put them in the right spot. You have an equation. Just plug those numbers right in. 4, simplify. So let's do this. First off, I see that it's a growth because it says growth. If we see increased growth, maximizes, those are exponential growth keywords. So the equation we're using is y equals a, 1 plus r to the power of x. So I am identifying a, r, and x. A is what I'm investing into Apple. That's also another thing you need to know that I didn't write on this slide. You need to actually write out what is it. So A is what I invest in Apple. I invest $500. R is the rate. I'm growing at a constant rate of 10%. So 10%. And X is our unknown time. X is always going to be your unknown time because that's what we're raising our exponent to. So we plug in what we know. A is 500. R is 10%, which we changed to a decimal. I put 0.10, and then X is just my exponent. Then I simplify. Y equals 500, parentheses, 1.10, parentheses to the power of X. And that's it. I have finished. I've answered the question. Okay, so what if we're posed with an actual question? Use this function to determine the total value of Lucas's investment after 8 years. So all we do is plug in 8 for X and solve it. So I will be plugging in 8 for X. This you can plug into a calculator. For these problems, rounding is a huge thing. What am I talking about? Am I talking about a person? Am I talking about a substance? Am I talking about what? If it's a substance, typically you don't round, you just keep the number as exact as possible. However, in this case, I'm talking money. And money only goes out 2 places to the 100th place. So I end up with Y equals 1,071 and 79 cents dollars. I wrote dollars afterwards, but that is my answer. Okay. So this was my exponential growth question. If you have any trouble, feel free to shoot me an email about that. And now example 2. So same steps, determine growth or decay, identify ARX, input values, simplify. Oh no, the dinosaurs are dying at an exponential rate. There are currently 80 dinosaurs remaining, and each month, 25% of the dinosaurs say adios. So I say dying, that is a decay. They are decreasing. So I am using Y equals A, 1 minus R to the power of X. So I need to determine what A, R, and X are. A is 80. What does that mean? There are 80 dinosaurs left. I started out initial value 80. R, 25%. They're decreasing by a rate of 25%. X is our unknown time. So plug in what we know. Y equals 80, parentheses, 1 minus 0.25x. So you might be asking, why do we do 1 minus? Like, what is the purpose of this? Okay, the purpose is because when I'm actually solving or inputting in for this equation, I want to know the remainder. Like, I want to know what's remaining. After I solve this, how many dinosaurs are actually left? Not how many did I lose? So I know that for each time, each month that passes, I know that I have 75% of dinosaurs remaining, 75% remaining, 75% remaining. 4 months later, 75%, like that. I know that it's constantly going to be 75% left of the number from before. Whew, that's a mouthful. So Y equals 80, parentheses, 0.75 to the power of X. After how many months will there only be about 14 dinosaurs still alive? So this is a little different than our last problem. Our last problem, we just had to plug in for the X and then just solve it in the calculator. However, this is more of a guess and check. So what I would do, this is how you set it up first. 14 equals 80, parentheses, 0.75 to the power of X. So I would guess and check. I know that 1 month is probably too soon to only have 14 from 80 dinosaurs left. So I would just, in my calculator, I would put 80 times 0.75 to the power of 2. 80 times 0.75 to the power of 3. 80 times 0.75 to the power of 4. So literally guess and check until we get to about 14. You're not going to get exactly 14, and that's okay. We're going to get about 14. So I'm not going to make you sit through all that. But at about 6 months, I see that I'm left with a little over 14, and that's what I wanted. Okay, So let's work through some previous star questions. So a population of 1,500 deer decreases by 1.5% per year. At the end of 10 years, there will be approximately 1,290 deer in the population. Which function can be used to determine the number of deer Y in this population at the end of T years? So that's another thing. Sometimes instead of using X, we'll go ahead and use T because I know it's talking about time. So those are interchangeable. Okay, so first thing I see is decreases. What does that mean? Exponential decay. Y equals A, 1 minus R to the power of X. So look at your answer choices. Eliminate anything that is not an exponential decay, like this one right here. It's got a plus sign. We're not adding anything. This is a decay. The other thing, remember, in that parentheses, it needs to be smaller than 1. So if I look at my answer choices, I can see the answer choice D has 1.5 in the parentheses. That's bigger than 1. So that would be a growth. So get rid of that too. So I'm going to go ahead and set this up. 1,500 parentheses 1 minus 0.015 because we move that decimal place 2 times. So 0.015 to the power of X. So I can already see that I'm matching A. However, I'm going to go ahead and finish this to see if maybe I can match B. So Y equals 1,500 parentheses 0.985 to the power of X. So no, it does not match B. And A is my answer. On B, you can see they forgot 1 minus, which is a common mistake. It will also be a common answer choice. So you need to make sure you're doing that. And then A, so let's look at another one. What if I have a table? How do I figure out the equation? So which equation of exponential growth best represents the following table of values? So growth, what does that mean? Y equals A, 1 plus R to the power of X. Okay, so do I have A? Do I have R? Do I have X? I don't know. I do have X's, 0, 1, 2, 3 are X's. However, I want the actual equation. So A is always my initial value or my y-intercept. How do I find a y-intercept from a table? I look for where X is 0, which is right here. They gave it to us. So this is always A. Wherever 0 is in the X side, that's always A. Just like in linear, y equals mx plus b. It's always B. Now it's always A. I know, confusing, but it makes sense. So, always A. Now I have to find R. How do I find R? That's easy. I just take my Y values and divide them. 8 divided by 4, 16 divided by 8, 32 divided by 16. What does that give me? It's a constant. It's going to be my R. And it is going to be 2. So I set this up. First things first. Process of elimination, people. A, 2 over X. X has to be an exponent. That's out. Next one, growth. Can't be less than 1 in that parentheses. 0.25 is less than 1. The next one, I just said that A is 4. So I can't have B. That doesn't make sense. So my only answer is D. And that's it. These questions are not difficult. It is kind of a lot of new information to remember. So just give yourself time to process and remember that. The rest of this week in class, today you're going to be doing some exponential growth and decay stuff. And tomorrow, starting on Wednesday, Thursday, Friday, we're going to do a little bit of a zombie apocalypse project. So get ready for that. And that's it. Bye guys. See you later.